Ready for a deep dive. Today, we're going where time itself takes a detour. We're tackling black holes. You know, those cosmic enigmas that just totally defy our everyday understanding of reality?
Yeah.
Our guide for this journey is this fascinating piece. It's titled, and I'll try to pronounce this right, Shea Oe.
Okay.
That's the pasted text in Arabic, in case you were curious.
Okay.
We're going to be uncovering how these gravitational behemoths form, the bizarre ways they just warp space and time. And we'll even touch on the mind-boggling possibility of black holes as these gateways to other universes.
It's going to be a journey that will challenge everything you think you know about the cosmos.
Okay, so let's just jump right in. The source kicks off with the dramatic origin story of black holes, the death of a star.
Right.
So imagine a star, way more massive than our sun. It runs out of fuel, and it just collapses in on itself under the force of its own gravity.
It's this cosmic implosion of just unimaginable scale. All that stellar material, once spread across millions of kilometers, gets compressed into a point of unimaginable density, a singularity.
Singularity. I remember reading that this is where the laws of physics, as we understand them, basically cease to function.
Precisely. A singularity is thought to be this point of infinite density and gravity, where space and time are warped beyond recognition. It's a concept that still really pushes the boundaries of theoretical physics today.
So, from the ashes of a dying star rises a singularity, a black hole. Now, the source mentions that there are different types of black holes, not just one size fits all.
Right. We have stellar black holes, which are the most common type, formed for the collapse of individual stars. Then you have the supermassive black holes, the true titans,
Yeah.
lurking at the centers of galaxies, including our own Milky Way. These behemoths can be billions of times more massive than our sun.
Billions of times. So if our sun were like a grain of sand, a supermassive black hole would be, what, like a giant boulder?
Perhaps even larger. And the influence of these supermassive black holes is truly immense. Their gravity governs the motion of stars and gas within their host galaxies, shaping their structure and evolution over billions of years.
So these supermassive black holes aren't just sitting there passively, they're actively shaping the galaxies they inhabit. It makes you wonder, how would our Milky Way look without its central black hole? Would we even be here?
That's one of the most fascinating questions in astrophysics. Without supermassive black holes, galaxies might look very different, and the conditions necessary for life as we know it might not have existed.
It's incredible how these seemingly destructive objects are actually essential for the universe as we know it. The source also mentions these in-between black holes, intermediate mass black holes. What's the story with those?
Intermediate mass black holes are still somewhat of a mystery. We haven't observed as many of them as stellar or supermassive black holes. They likely form through different processes, perhaps from the mergers of smaller black holes. Studying these missing links is crucial for understanding the full spectrum of black hole evolution.
Okay, so we have these black holes, these gravitational monsters, scattered throughout the universe. But what happens if you get too close? The source talks about this ominous-sounding boundary called the event horizon.
The event horizon is the point of no return. Cross it, and there's no escape, not even for light itself. It marks the boundary where gravity becomes so intense that it warps the fabric of space and time, making escape impossible.
It's like falling off a cosmic waterfall with no way to climb back up. I read somewhere that if I were to fall into a black hole, from my perspective, time would seem to flow normally, but to someone watching from a safe distance, I would appear to slow down, like a record player winding down.
That's exactly right. It's one of the most mind-boggling consequences of Einstein's theory of general relativity. Time is relative, meaning it flows differently depending on your frame of reference and the strength of the gravitational field you're in.
So if I were falling into a black hole, I wouldn't notice anything unusual about time. But to an outside observer, I would be stuck in this perpetual slow-motion descent. It seems to defy all logic.
It does, doesn't it? But time dilation isn't just a theoretical concept. It's been experimentally verified, even here on Earth. Atomic clocks at different altitudes experience slightly different rates of time due to Earth's gravity. Of course, near a black hole, this effect would be dramatically amplified.
So black holes aren't just these theoretical curiosities, they're real-world laboratories for testing the limits of physics. And what I find fascinating is that this warping of space and time, this time dilation, could potentially lead to, well, let's just say some very interesting possibilities. The source even mentions a possibility of black holes as portals to other universes.
That's where we enter the realm of speculation. But it's a captivating idea nonetheless. It's based on the concept of wormholes, or Einstein-Rosen bridges, which are theoretical tunnels that connect different points in spacetime, perhaps even different universes.
So instead of being trapped forever inside a black hole, maybe you could emerge somewhere else entirely, another universe, another dimension. That raises so many questions. Would those universes have different laws of physics? Would time flow differently? Could there be other forms of life out there?
These questions are at the forefront of theoretical physics and cosmology. While the idea of black holes as gateways to other universes remains speculative, it fuels our curiosity and drives us to explore the boundaries of our understanding. It highlights just how much we still have to uncover about the universe and its most extreme phenomena.
All right, so far we've covered how black holes form, their different types, and the mind-bending effects they have on space and time. But the source also makes it clear that black holes aren't just cosmic destroyers, but they also play a vital role in shaping galaxies. It's almost like they're the architects of the universe.
That's a great way to put it. While they might seem like engines of destruction, their gravity and the powerful jets of energy they emit are essential for the growth and evolution of galaxies. Let me explain.
Please do. I'm all ears.
Imagine a supermassive black hole at the center of the galaxy. Its immense gravity pulls in surrounding gas and dust, creating a swirling disk of material called an accretion disk. As this material spirals inward, it heats up to millions of degrees, emitting intense radiation.
So it's like a cosmic whirlpool with matter spiraling down the drain towards the black hole.
Exactly. But here's the twist. Not all of this material falls into the black hole. Some of it gets ejected outward in these powerful jets that can extend for thousands of light years.
Thousands of light years. That's mind-boggling. What are those jets made of?
They're composed of incredibly hot, energized particles, traveling at nearly the speed of light. These jets can heat and ionize the surrounding gas, influencing star formation and shaping the overall structure of the galaxy.
So it's not just the black hole's gravity that's shaping the galaxy, it's also these powerful jets blasting out energy and influencing the environment for millions of light years around. It's almost like a cosmic sculptor molding the galaxy with its gravitational pull and these energetic jets.
Precisely. Black holes play a much more nuanced role than we initially imagined. They're not just devouring matter, but also regulating its flow and distribution, influencing the evolution of galaxies in complex ways.
It's amazing how these seemingly destructive objects are actually key players in the grand cosmic drama. They're shaping the universe as we know it.
And there's still so much more to learn about the intricate dance between black holes and their host galaxies. We're just beginning to unravel the complexities of their relationship.
Well, I'm definitely hooked. We've explored how black holes form, the different types, their mind-bending effects on space and time, and even their role in shaping galaxies. It's been a whirlwind of information, but I feel like I'm just starting to grasp the sheer wonder and complexity of these cosmic objects.
And we've only just scratched the surface. There's a whole universe of knowledge waiting to be explored. In the next part of our deep dive, we'll delve into the groundbreaking work of the Event Horizon Telescope, the challenges and triumphs of observing black holes, and the tantalizing possibilities of future discoveries.
So if you're ready to journey even deeper into the heart of these cosmic enigmas, stay tuned.
Welcome back to our exploration of black holes. As we delve deeper, we'll uncover how scientists are pushing the boundaries of observation to actually capture these elusive cosmic giants.
I'm still trying to wrap my head around the whole idea that time itself can be distorted near a black hole. But I'm eager to hear how researchers are tackling the challenge of actually observing these invisible objects. The source highlights this project called the Event Horizon Telescope, or EHT, which has been making headlines.
The EHT represents a monumental achievement in astronomy. It's not a single telescope, but a global network of radio telescopes, all synchronized to observe a target with just incredible precision.
So it's like combining the power of multiple telescopes spread across the world.
Exactly. This technique, called very long baseline interferometry, effectively creates a virtual telescope the size of Earth, enabling the EHT to resolve details that would just be impossible with a single telescope.
Yeah. I recall seeing that groundbreaking image the EHT captured the first ever picture of a black hole. It was blurry, a ring of light, but I remember thinking, wow, we're actually seeing the shadow of a black hole.
That image captured the supermassive black hole at the center of the galaxy M87, millions of light years away. It was a remarkable feat, really demonstrating the power of human collaboration and ingenuity to unlock the secrets of the universe.
But how can we even see a black hole if light can't escape its grasp?
Well, the EHT doesn't directly observe the black hole itself. It captures the shadow cast by the black hole against the bright background of its accretion disk. That swirling disk of superheated gas and dust spiraling into the black hole.
So we're seeing the silhouette created by the black hole's immense gravity as it warps the path of light around it.
Precisely. The bright ring we see in the image is the radiation emitted by the superheated material in the accretion disk. The black hole's gravity bends this radiation, creating that distinctive ring-like structure.
It's like a cosmic lens, magnifying and distorting the light from behind it. The source mentions that this image wasn't just a visual spectacle, though. It also provided valuable data that allowed scientists to test Einstein's theory of general relativity in an extreme gravitational environment.
Yeah. Einstein's theory predicted that massive objects like black holes warp space and time around them, and the EHT observations confirm those predictions with remarkable accuracy. It's another triumph for our understanding of gravity, even in the most extreme conditions.
It's fascinating how these observations push the boundaries of our scientific knowledge. The source also mentions that the EHT isn't done yet. They're working on capturing even sharper images and expanding their observations to other black holes, including the one at the heart of our own Milky Way galaxy.
The prospect of observing our own galaxy's supermassive black hole in such detail is incredibly exciting. It could reveal new insights into the role these giants play in galactic evolution, and perhaps even uncover new phenomena that challenge our current understanding.
It's like having a front row seat to a cosmic fireworks show, but I imagine observing black holes comes with its own set of challenges. After all, we're talking about objects millions, even billions of light years away, shrouded in darkness.
The challenges are immense. Black holes are incredibly faint, difficult to detect. One of the key methods for finding them is to study their gravitational influence on nearby objects. For instance, if we observe a star orbiting around an invisible but massive companion, we can infer that it's likely a black hole.
It's like a cosmic detective story, piecing together clues to uncover the presence of these hidden giants.
Exactly. Another method involves detecting the radiation emitted by matter as it falls into a black hole. As material spirals towards the event horizon, it heats up to incredible temperatures, emitting X-rays and other high-energy radiation that we can detect with specialized telescopes.
So it's not just about observing the absence of light, but also the intense radiation emitted by the material being consumed by the black hole.
Precisely. But observing this radiation comes with its own set of hurdles. The black hole's intense gravity warps the path of light, distorting our view of the surrounding region. Scientists have to use sophisticated computer models to account for these distortions and reconstruct a more accurate picture.
So it's not just about collecting data, it's about unraveling this intricate tapestry of light that's been warped and twisted by the black hole's gravity. I can see why this field of research requires such a blend of observation, theoretical modeling, and computational power.
It's a true interdisciplinary effort, pushing the boundaries of astronomy, physics, and computer science. And the rewards are immense. Black holes offer a unique window into the most extreme environments in the universe, allowing us to test our fundamental theories about gravity, space, and time.
The source also mentions these broader implications of black hole research. It seems that these objects, once considered mere cosmic oddities, hold clues to some of the biggest mysteries in cosmology.
Black holes are no longer just objects of fascination. They've become essential tools for probing the fundamental nature of the universe. By studying them, we can push the limits of our understanding of gravity, explore the nature of space and time, and even shed light on the mysteries of dark matter and dark energy.
Dark matter and dark energy. Those elusive entities that make up the vast majority of the universe, yet remain invisible to us. How are black holes connected to these cosmic mysteries?
Well, some theories suggest that black holes might play a role in the formation or behavior of dark matter and dark energy. Others propose that studying the interactions between black holes and their surroundings might provide clues about the nature of these enigmatic substances.
It's like black holes are these cosmic laboratories, offering us a glimpse into the unknown realms of the universe. But I'm also curious about the future of black hole research. What new discoveries are on the horizon? What technologies are being developed to unlock further secrets?
The future of black hole research is brimming with potential. Scientists are developing next-generation telescopes, both on Earth and in space, with even greater sensitivity and resolution, allowing us to peer deeper into the hearts of black holes.
So we'll be able to see these cosmic giants in even greater detail, capturing images with incredible clarity.
Exactly. And these advancements will allow us to study the dynamics of gas near the event horizon, measure the spin of black holes with unprecedented precision, and perhaps even detect gravitational waves emitted by black hole mergers.
Gravitational waves, those ripples in space-time caused by the acceleration of massive objects.
The very same. Detecting gravitational waves from black hole mergers would be a monumental achievement, providing us with a new way to listen to the universe and study these cataclysmic events in unprecedented detail.
It's amazing how we're constantly expanding our toolkit for exploring the universe, adding new senses to our cosmic perception. But I imagine these advancements in observation go hand in hand with theoretical modeling and computation.
Absolutely. As we gather more data, we need increasingly sophisticated models to interpret that information and make predictions about the behavior of black holes.
So it's a constant interplay between observation, theory, and computation driving the field forward, like a cosmic dance, with each element informing and enriching the others.
It's a truly remarkable journey of discovery, and we're just beginning to understand the profound implications that black holes have for our understanding of the universe and our place within it.
Well, I have to admit, I'm feeling a bit overwhelmed by the sheer scale of information and the profound questions we've been grappling with.
It's certainly a lot to digest, but that's the beauty of exploring the cosmos. There's always more to discover, always another layer of complexity to unravel.
Perhaps a short break is in order before we delve into the final part of our deep dive. We'll be back soon to wrap up our exploration of black holes and address some of the biggest unanswered questions that still linger.
Stay with us. The journey is far from over.
Welcome back to our deep dive into black holes. We've covered a lot of ground, from their formation to their role in shaping galaxies, but as with any good mystery, the more we learn, the more questions we uncover.
Right, that's the nature of scientific exploration. Every answer often leads to a whole new set of questions, and black holes are no exception. In fact, they present us with some of the most profound and perplexing puzzles in physics.
So let's dive right into those puzzles. What are some of the biggest unanswered questions that keep scientists up at night when it comes to black holes?
Well, one that has baffled physicists for decades is what happens at the singularity. That point of infinite density at the heart of a black hole.
Yeah.
Our current laws of physics break down at the singularity, which leaves us with more questions than answers.
It's like staring into the abyss of the unknown. I remember reading that even the concept of space and time, as we understand them, ceases to have meaning at the singularity.
Precisely. It's a realm where our current understanding of reality simply doesn't apply. Some theories speculate that matter might be crushed out of existence at the singularity, while others propose that it could transform into a new state of matter entirely.
Could it even be a gateway to another universe like we discussed earlier?
It's a possibility, though a highly speculative one. The singularity is a point where our knowledge and imagination really collide, pushing the boundaries of theoretical physics. Unfortunately, observing the singularity directly is impossible, shrouded as it is by the event horizon.
Yeah, it's almost like a cosmic vault, just locked away from our prying eyes. The source also mentioned another head-scratcher, the information paradox. It sounds like it goes to the heart of some really fundamental principles in physics.
The information paradox arises from a conflict between quantum mechanics and general relativity, two pillars of modern physics.
Okay.
Quantum mechanics tells us that information can never be truly destroyed, while general relativity suggests that anything that falls into a black hole, including information, is lost forever.
So which one is right? Can information be destroyed in a black hole, or is it somehow preserved? It seems like a pretty fundamental question.
It's a question that has sparked intense debate among physicists. Some propose that information might be encoded on the event horizon itself, while others suggest that black holes might not completely destroy information, but rather scramble it in a way that makes it practically impossible to retrieve. Imagine throwing a book into a fire. The book burns, but the information it contained, the words, the stories, is dispersed into the smoke and ashes. In a similar way, information falling into a black hole might be dispersed, but not completely destroyed.
That's a really helpful analogy. It seems like the information paradox highlights the limitations of our current understanding of physics, particularly when we're dealing with these extreme environments like black holes.
Exactly. It's a puzzle that continues to drive research, challenging us to reconcile these seemingly contradictory theories and develop a more complete understanding of the universe.
Okay, so we have the enigma of the singularity and the information paradox. Are there other big questions out there that black holes pose?
There are many. One area of active research focuses on the relationship between black holes and the evolution of galaxies. We've talked about how supermassive black holes influence the motion of stars and gas, but the details of this interplay are still being actively studied.
So it's not just a one-way street. With black holes dictating the behavior of galaxies, there's a kind of feedback loop happening.
Precisely. As a black hole grows, it releases energy that can heat and push away surrounding gas, which can in turn affect the rate of star formation. It's a delicate balance, and understanding this complex relationship is key to understanding the evolution of galaxies, including our own.
It's like a cosmic dance, with black holes and galaxies influencing each other in this intricate choreography over billions of years. The source also touched on this mind-boggling concept of black holes as potential gateways to other universes.
Right.
It seems like we've stepped firmly into the realm of science fiction here.
It's certainly a captivating idea. But, as we discussed earlier, it's based on the concept of wormholes, which are theoretical tunnels that connect different points in space-time, perhaps even different universes.
Yeah.
While mathematically consistent with Einstein's theory of general relativity, wormholes remain hypothetical. We haven't observed them directly, and the conditions required for their existence are, to put it mildly, extraordinary.
So the idea of black holes as portals to other universes is intriguing, but still very much in the realm of speculation.
Exactly. But that doesn't diminish its allure. It sparks the imagination, pushing us to question the limits of our understanding and the nature of reality itself.
And that, in a way, is what makes black holes so captivating. They're not just objects of scientific study, they're also windows into the unknown, challenging us to confront the mysteries at the heart of the universe.
They force us to ask profound questions about the nature of space, time, matter, and the very essence of existence. In a sense, they're a reflection of our own quest for understanding. Our drive to explore the boundaries of knowledge and push beyond the limits of what we think we know.
As we wrap up this deep dive, I'm struck by a sense of awe at the sheer scale and complexity of the universe. Black holes, once considered mere cosmic oddities, have become central to our understanding of the cosmos.
They're not just objects of destruction, but also engines of creation, shaping galaxies, influencing the evolution of stars, and pushing the boundaries of our scientific understanding.
It's a journey of exploration that's far from over. Who knows what new discoveries await us as we continue to peer into the depths of these cosmic enigmas? Maybe one day we'll unlock the secrets of the singularity, solve the information paradox, or even find evidence of other universes lurking beyond the event horizon.
Until then, the mystery and wonder of black holes continue to inspire us, reminding us that the universe is a place of infinite possibilities.
Thank you for joining us on this journey into the heart of black holes. Keep looking up at the stars and keep asking questions. The universe is full of wonders waiting to be discovered.